Hello. So good morning. Hello and welcome to the last and the final session of this course, Availability and Management of Groundwater Resources. Uh, Today we will be going through the point area of focus for the previous week's lectures, particularly lectures of from week 5 until week 12, and what kind of questions are going to come from certain areas. The last week we had covered so the last week we had covered portions from week 1 to week 4. So this class will be covering from week 5 to week 12. So let's get on with the revision focus points and the revision points. So first we'll start with the 5th week's lecture series. So in the 5th week lecture series, it was majorly dealing with concepts like transmissibility, the relationship of transmissibility with permeability and depth. So questions like these can come, which is asking you for the definition for the relationship of transmissibility with permeability and depth. You will have to focus on what is the definition of transmissibility. It is the permeability through a portion of the aquifer medium. Now, when we consider the entire aquifer medium, when you take a portion of it, what is the capacity of capacity of that aquifer or that portion to transmit water is what is transmissivity. So the points of focus would be the definition. You will have to learn this relationship between hydraulic conductivity and thickness of the aquifer, and also what are the units of this transmissivity component. Its dimensions are in terms of L square by T, where meter square per second or meter square per day or meter square per hour can be the units. So problems based on this will be coming, and the relationships also can come. Then it is all the lecture is also focusing on the coefficient of permeability, which is nothing but hydraulic conductivity. So what is the coefficient of permeability? What are the factors that are impacting coefficient of permeability? Then what is the permeability permeability depends on the soil texture. So to different kinds of soil with different textures, what is the permeability in different soils, like sandy soil, clay soil, and also based on the arrangement structure of the soil, what is the permeability to different types of soil is also one point of importance in the week 5. Then another important concept is the storage coefficient or storativity. So what is storage coefficient, storativity? It is actually the correct definition is the volume of water that is drawn or that you can obtain from per unit cross-sectional area of the aquifer per unit drop in hydraulic head. So for say if you're taking it in meters, for 1 meter drop of hydraulic head and 1 meter square area of the aquifer, what is the volume of water that you can get is what storativity or storage coefficient is defined as. And you should also focus on confined and unconfined aquifers. What is the storage? How is the definition changing? Then other concept is the porosity, then amount of pores in the aquifer medium. So what is the definition of porosity? What is the mathematical representation of porosity? What is void ratio? Again, what is the mathematical representation of void ratio? and the relationship between porosity and void ratio. These 4-5 concepts are very important. So the definition of porosity is nothing but the ratio of the volume of pores to the entire volume of the soil, whereas the void ratio is the ratio of the volume of pores to the volume of the soil particles alone, not the entire volume, but the soil solids alone. So it is represented by N. Porosity is represented by N and void ratio by E. And how is it mathematically expressed as something that you will have to focus on. Then again, what are the factors on which porosity depends? It is depending on the shape of the particle, depending on the packing of the particle, and also how well are the soil particles graded or sorted. So these are questions based on this can come asking what is it depending on, what is it independent of. Another part is the bulk modulus of compression that is coming in connection with the storativity or storage coefficient. So storage coefficient is given by this formula, and another formula that is there are a couple of portions that is taking care of the storativity or storage coefficient, and bulk modulus is coming in relation with this equation. So it will be good to have an idea about the bulk, what is bulk modulus of compression, and what are the values of bulk modulus for compression for different soil material. Then problems are a very important part of this chapter relating to transmissivity. They can give the transmissivity. They'll ask you to find the thickness of the aquifer, or they can ask you to find the hydraulic conductivity of the aquifer, or they can ask you to find the transmissibility by giving the hydraulic conductivity and the thickness of the aquifer. Then problems like these can also come where they'll ask you what is the relation between porosity and the void ratio. N is equal to E by 1 plus E. Is 1 plus E is the relationship between porosity and void ratio. Then again, they can ask problems based on this formula. They can also ask you the problems to find void ratio by giving the volume of the pores and the volume of the solid particles. So such problems can also come in this from this portion. Another concept is what is effective porosity, otherwise kinematic porosity. So if again this is taking a portion of the void spaces in a porous material, if you consider a part of the porous material, then what is the effective pores? If you consider from the total pores, what is the amount of pores through which water actually flows? Is what is the basic concept of what effective porosity or kinematic porosity is. So you will have to focus on what is the definition and these terms, kinematic and what is effective porosity. So summarizing, this week's lecture will be focusing on what is permeability, what is the permeability to different types of materials, what are the factors affecting permeability. There is a mathematical representation, CD square into gamma W E by 1 plus C. So if you learn that formula itself, you can understand what are the factors on which the permeability, otherwise coefficient of permeability depends on. So that is one important part of this lecture series. Then again, how is the permeability varying according to soil texture and soil structure for different types of soil? For sandy soil, for clay soil, what will be the permeability? Will it pass through it easily, or it is not going to pass through it easily? Then again, there's a portion that is dealing with the types of permeability and averaging techniques of permeability. Then again, transmissivity, what is its definition, unit, relationship, and also problems. And what is the transmissivity definition in terms of confined and unconfined aquifer. Another concept is the intrinsic permeability. So you'll have to focus on that also. Then storativity and storage coefficient for confined and unconfined equation. So this entire all these are the focus points of the week 5 lecture. So you can use this as a guidance to help you to study the week 5 motion. Moving on to the revision point for week 6. Again, week 6 is covering portions relating to Darcy's law. So what is Darcy's law is something that I think we have covered in earlier week's lectures. So what is Darcy's law? What is the validity of Darcy's law? Now, Darcy's law is only valid for slow viscous flow where the Reynolds number is less than 1. That is, if the flow is laminar. So what is the validity of Darcy's law and what are the assumptions of Darcy's law is an important part of this chapter. So have an idea about these points on what are the assumptions considered when we talk about Darcy's law. Then so such questions can come, asking for the validity of Darcy's law, what is it valid, what kind of flow it is valid for, what kind of Reynolds number it is valid for. Then there are concepts that are covering what is traveling time of the groundwater, velocity of the groundwater flow. So we know velocity of groundwater flow is given by the Darcy's equation. What is the traveling time, traveling distance of water and traveling time of water in groundwater flow is given by this formula. The length divided by the velocity into porosity is the formula. And here the length is always considered in kilometers, whereas the velocity is considered in meters per day. So you might need to focus on the units of this equation. Another important equation is the velocity of tracers through aquifer. This is nothing but again distance by time. The distance between two wells. Questions will come where they are passing a tracer and the velocity of the tracer that is passed between two wells. So the distance between the two wells will be given, which will be r, and the time taken for the tracer to travel through this will be given, which is t, and we will be asked to find out the velocity. So this is the type of question I was talking about. If the distance is given and time is given, so what is the actual velocity of the tracer? Then, yes, this is something we covered in the earlier week's lecture, week 5. This is a formula that I was talking about. So these are the factors on which the permeability depends on. C is the factor that is covering all the grain size distribution, texture, and structure of soil. D is effective grain size of the soil through which this is happening, water is passing. Then the unit weight of water, dynamic viscosity of water, and the porosity of the soil medium. So these are all factors on which permeability depends on. So questions like these can come. Which of the following factors affects the permeability of the soil? Another portion in relation to this, we learned about what Reynolds number is in connection with the Darcy's law. So what is the mathematical representation of Reynolds number? It is inertia force by viscous force. And also what is the formula? That is rho Vd by mu, where rho is the density, V is the seepage velocity, D is the grain size of the aquifer material, and mu is the dynamic viscosity. So this formula you need to be familiar with, and also this mathematical representation of Reynolds number. Questions and numericals are highly likely to come from this portion. So they can give you the density. We know the density of water. They can give you the dynamic viscosity, the velocity, and the grain size of the aquifer material, and they'll ask you to find what is the Reynolds number. Now, if the Reynolds number is much greater than 1, then it will be turbulent flow. So turbulent flow, Darcy's law is not valid. So questions like that can also come. Check the validity of Darcy's law for a flow that is happening where the dynamic viscosity is so and the seepage velocity is so, and the grain size distribution or the grain size of the material is this much. So check the validity of Reynolds Darcy's law. Such questions can also come. Now, then another thing that is in focus in this week's lecture is the seepage velocity. So we know discharge velocity is computed using Darcy's law. In the same way, seepage velocity is nothing but the velocity, the discharge velocity divided by the porosity is the seepage velocity. So when we consider the entire cross section of the aquifer for the computation of the velocity of water through the aquifer, then seepage velocity is the velocity of water that is flowing through a single pore or a connection of pores. So that is, you have to find that velocity of water is greater, the seepage velocity is greater than Darcy's velocity because the cross-sectional area is smaller in this case. Again, what are the coefficient of permeability for different types of soil? It is ranging from 1 into 10 to the power minus 6 to 100 centimeter per second. So how does it vary? I mean, even if you don't have an idea about the range, from what range to what range does it vary, and in what order does it vary is something that you might have to focus in this week portions. Then another important portion is the what is the total energy of water. Total energy of water is given as a sum of the pressure energy, elevation energy, and the kinetic energy. Pressure energy is nothing but the head of the water as a result of the pressure. Elevation energy is the height of the water column as a result of its position. And the kinetic energy is the energy of the water as a result of velocity. So what is pressure energy? What is elevation energy? What is kinetic energy? Another thing is, what is the other names for this? Elevation energy is also said as datum head, and kinetic energy is also called as velocity head or dynamic head. Pressure energy is also called as pressure head. So what are these kinds of energy? Questions like these, energy possessed by virtue of its position or state. By virtue of position, it is called elevation energy, and energy possessed by virtue of its state is called the pressure energy. So this is the mathematical representation of the total energy of water in terms of head. Kinetic energy is given by V square by 2G. Pressure energy is given by P by rho G, and elevation energy or datum head is given by Z, which is the elevation of the water. I mean, the bottom of the water body. If you're considering a total height of h, then how much height is contributed by the how much is the bottom of the water, level of the water at the bottom from the mean sea level will give us the elevation energy. So questions like this will come where they are asking you to choose the correct expression for total energy of water. Now, another portion in connection with this is the hydraulic head. Now we learned about pressure head, elevation head, and kinetic head. Hydraulic head is nothing but the sum of the pressure head and the elevation head is in together is called the hydraulic head. So let's go back and talk about hydraulic gradient. Hydraulic gradient is nothing but the change in the pressure head divided by the length of the flow. So you have to know what is the relation between hydraulic, what is the difference between hydraulic head and the pressure head. Hydraulic head is a sum of both of this. Pressure head will be just this. So, and problems like these are bound to come again, making use of the Darcy's equation. I is the hydraulic gradient, which is given as the difference between the heads of the water. That is the total head of the water divided by the length of travel of this groundwater. So the question will come saying that hydraulic conductivity is given, and they have said that two piezometers are located at this much distance, which will give us the length. Water level is known, which is 1 meter and 1.5 meter. So the difference in this water level is going to give delta H. The formula for I, hydraulic gradient, is delta H by L. So delta H is the difference between these two heights. So this is a direct substitution question, but we just know we need to know what the terms are representative of. And also problems relating to traveling time of water. They have said the porosity they have given, traveling time is distance they have given. They've asked us to find the traveling time. So here they've asked to find out, the velocity was found out earlier from this question, and in continuation with that, we have been asked to find out the traveling time. So another important thing is this 30% should always be converted to 0.3, and also take care of the units. Like I said, traveling time, normalize all the units, bring it to 1 unit, kilometers to meters. This one, if they have asked in years, to make sure that the velocity component, which is giving us meter per second, is converted to meter per year. Again, we talked about it. What is intrinsic permeability in the previous chapter? So again, what is intrinsic permeability? It is nothing but C into D square. D square is the grain size, and C is representing all the other factors on which the permeability depends. That is the geometrical properties of the porous media. And Darcy This K is expressed in centimeter square is very small. So there is a unit exclusively for this, which is called 1 Darcy. So what is the relation between the Darcy and centimeter square? And what is the relationship of intrinsic permeability with coefficient of permeability are two very important factors that you will need to focus on. So summarizing this week's focus points, it will be water movements. What is hydraulic head? What is pressure head? What is kinetic head? Datum head? What are again the factors affecting permeability? Velocity of water through ground during groundwater flow, as well as seepage velocity, the travel time of tracer, the actual velocity of tracer. All the formulas and problems are important. Then Darcy's law, validity of Darcy's law. What is the mathematical representation of Darcy's law? What are the assumptions in Darcy's law, and the problems related to Reynolds number and everything are important. Then there are empirical formulas for ground to find out the groundwater velocity. You can go through the lecture medium for that. And also confined and unconfined aquifers, problems relating to finding the discharge through aquifers. What is the value of drawdown? What is the radius of the well? What is the radius of influence? Etc. So this this portion is being covered in the next week's lecture also. So we'll just see what all are that. Even in this chapter, there are portions that are talking about the 6th point. So moving on to the 7th week, we have they're focusing on some hydrological components like the runoff. So what is runoff? What are the empirical formulas to calculate runoff? Formulas like Barlow's formula, all are empirical formulas. So special focus on the units. So Barlow's formula, Angelus's formula, Kosla's formula, Lacey's formula. Be familiar with all of those, and also the units in which all the quantities are represented. Problems can come from this, asking you to estimate using Barlow's formula or Angelus formula by giving the respective data. Then this was what I was talking about. You need to be having an idea about what is drawdown. Drawdown is the height of the actual water table from the initial water table, and from the water table to the from the initial water table to the present water table. And what is the difference between drawdown and height of the water table are two concepts that you need to be very clear with, because the problems will be given like that. They'll give you drawdown value, or they'll give the height of the water table. So height of the water table is the total height of the water table minus the height of the water in the well. The drawdown is equal to that. Then what is radius of influence? What is the total height? What is the pumping discharge rate? Where is the radius of the well coming, and what is the distance of the center of the well from another well will be provided. So that value is going to be small r. So here is a problem that can come in relation to it. They'll give you the radius of the well. They will give you the distance of a well from the center of the pumping well, another well from the center of the pumping well, which are R1 and R2. They'll give you the height of the water level, actual water level. Two heights they can give. You will have to find the drawdown from that. They'll give you the radius of influence. They'll give the discharge rate, and you're supposed to find out the discharge. In this question, they have asked to find out the permeability, coefficient of permeability. So now this equation, you need to understand, is different for confined as well as unconfined aquifer. So you have to be familiar with the formula for confined and unconfined aquifer, which is in this way. This is for unconfined aquifer. For confined aquifer, the formula is different. So please be familiar with this concept. A problem relating to this is pretty sure to come. So this is the kind of problem that can come. The discharge is given, drawdown is given, the distance of the wells from drawdown is given, and the distance of the observation wells are given. They have asked to find the coefficient of permeability. Another next important point of focus in this week 7 is the different types of well. So what are the classifications of well? Open well, sorry. What is well? What are the classifications of well, open wells and tube wells? what are the discharge rates and the diameters and lengths of open wells generally. What is the classification for open well, shallow open well, and deep open well? What is the shallow open well? Shallow open well is when the well ends in the water bearing strata itself, and deep open well is when it ends in the impervious strata called motta layer. So that, then again, what are tube wells? What is going to be the discharge? Generally, what is the discharge in tube wells? And what is the diameter of tube wells? What are the classifications of tube wells, shallow and deep tube well? Again, here, what will be the discharge for shallow well and deep tube well? What is going to be the depth of shallow and deep tube well? Uh, have in mind all these values. Then, yeah. Also, there are other types of well like bored well, driven well, and jetted well also talked about. So, have an idea about what they are, what are the dimensions of the diameter and depth will be something that you might need to go through. And yeah. The next concept in here is what is a hydrograph. Hydrograph is the discharge versus time graph, which is giving us an idea about, which is helping us estimate the direct runoff. And hydrograph has got various components like rising limb, peak discharge, falling limb. So what is all that is given in the lecture series. So please do go through all that. Questions like what is this plot called as can come. Then yeah, there is an important terms related to pumping given. Be very sure to go through the slide, which has got all definitions of cone of depression, what is drawdown, what is area of influence, what is radius of influence. All these are given. So once you go through this, you will be able and go through that figure which is given in relation to the problem and correlate and study. You will be able to understand these concepts related to pumping. So again, so week 7 focus point is again runoff, empirical formulas for the estimation of runoff, hydrograph components, types of wells and the specifications, and the steady flow in confined and unconfined aquifers. So week 6 and week 7 both has topics related to it. So these are the focus points in these week 7 lectures. Now moving on to the 8th week's points. 8th week is covering portions related to rainfall. So what is precipitation? What are the different types of rainfall classification? What are the different types of precipitation classifications? It can be snow, it can be rain, it can be sleet, hail, whatever. So one portion that is majorly covered here is how to estimate the mean rainfall over a basin. So using 3 methods, the arithmetical mean method, Theisen's polygon method or mean method, and these slides have if you have access to these slides, you can see that what this Tyson polygon method is, what is isoheitel method. Out of these 3 methods, which is the best method also, you'll have to know. Then problems relating to this can come, which is the most accurate method, and they can give you 4 or 5 rainfall, the areas of isoheight or something like between isoheights, and ask you to find out the mean rainfall. Another important portion is the gauges, that is measurement of gauges. That was empiric equations to calculate the mean rainfall, average rainfall. Here they're talking about the how to measure rainfall. So there are major 2 types of rainfall recording gauges and non-recording gauges. Non-recording gauges, Simon's gauge is the non-recording gauge that talked about in this. And what are the specifications of it? The diameter, what is the funnel that is used for collecting the water, collecting a bottle, all that. Then the 3 types of recording gauges: tipping bucket, weighing bucket, and natural siphon type of floating type. So what are all those? What is a tipping bucket? What is floating recording type? What is a weighing bucket type? All of this is important that you go through. So they can ask you again questions like this: where it is used and in which kind of rain gauge is recording possible. So all of these recording gauges are making a record of the mass curve of the rainfall, that is accumulated rainfall. This is about weighing bucket type, and this is about the natural siphon type. Now, another important point is when is the period of measurement of rainfall when it comes to non-recording gauges. It is taken at 8:30 a.m. In one day until 8:30 a.m. the next day is how the rainfall is measured. 124 hours of rainfall for that day is measured in this way. So questions related to all these recording gauges are sure short. There is at least one question going to come from that portion. So have an idea about it. Another portion that is being covered here is the what is an average annual rainfall or normal annual rainfall. So when we take it for 1 year, it is called annual rainfall. When you take it for 30 years and find the average of all the 30 years annual rainfall, we call it average annual rainfall. And that is one standard value with which all the other rainfall, small time series, that is daily values or annual values are compared. So average annual rainfall or normal annual rainfall is the rainfall that is taken for a period of 35 years or 30 years. And it is based on this that you can find the index of wetness, which is nothing but the ratio of the annual rainfall by the average annual rainfall. So based on the index of wetness, we can find out if a year is a good year, a bad year, or normal year, because if the annual rainfall is less than the average annual rainfall, then this will be the uh, uh, representation of that year in terms of rainfall. Also, deficiency also can be found out. So this is another important concept here, the average annual rainfall, or it is also called the normal annual rainfall. Okay, and index of wetness is quantity that is used with in relation to this average annual rainfall. So questions like this can come based on this data over here. This is one question that is discussed. Another important is the design of rain gauge network for different kinds of area. This is according to IAS recommendation. For plain area, how many rain gauge stations has to be provided per a certain area. So for plain areas, you're providing one station per 520 kilometer square. For areas having elevation of 1000 meters, this much one station you have to give for this much area. And for very hilly areas, one station per this much area. So this is one table that you'll have to remember. Another concept is the optimum number of rain gauges. N is the optimum number of rain gauges. This is the coefficient of variation of the rainfall, and this is the standard error that is allowed. So this formula is important. Not only that, how to find CV. CV is equal to the standard deviation by mean into 100. Standard deviation you can find using this equation. So problems relating to this can come. And they'll ask you to find the optimum number of rainfall gauges. The question will be like this. They'll give you a certain amount of gauges. Now, how many more gauges should be placed there? So if the optimum number of gauges is 9, and if only 5 rain gauges are there, then 9 minus 5, 4 more rain gauges has to be placed there. Again, I talked about recording gauges, recording data, which is the mass curve of rainfall given by this graph. That is accumulated precipitation in chronological order versus time gives us the mass curve of rainfall. So most of the recording gauges, that is the floating type, weighing bucket type, all make this plot. I mean, when they are recording, it is recorded in this way, and that is called the mass curve of rainfall. Then, a very important concept is the infiltration. What is infiltration? What is infiltration capacity? And the relation between actual rate of infiltration and infiltration capacity and the intensity of rainfall. So have a look at this slide and go through and read and understand what is the relation when the actual rainfall is greater than the actual infiltration rate. What will be the infiltration capacity, or the actual rainfall is less than the infiltration rate, what is going to be the infiltration capacity, and how is runoff related to this is one important part of this week's lecture. So there are various equations that are used for computing infiltration rate. Horton's equation, Phillips equation, Kostykov's equation, Horton's equation. You can study the equation. Problems can come relating to that. This is Horton's equation. So summarizing, week 8's lecture is covering what is rainfall, what are the different formations of rainfall, that is orographic precipitation, cyclonic precipitation, what is all of that. What are the different forms when the rainfall's intensity, what is it, light rain, heavy rain. Then based on the size of the drops, what rain is it? Is it a drizzle or it is a big droplet or whatever? All of that is covered in this portion. Measurement of rainfall, we saw recording, non-recording gauges. Estimation of mean rainfall, we saw arithmetic method, Thiesen's polygon, and isohydral method. Estimation of missing rainfall is some portion I think we didn't cover, but do go through that. Then index of wetness and normal rainfall. Design of rain gauge network, we checked that table. Then the optimum number of rain gauges is one important part. Infiltration. What is infiltration? Infiltration capacity, the relationship between infiltration and rainfall intensity, infiltration equations. Another thing we had discussed during the problem sessions as well is the phi index and the W index. So what is phi index? What is W index? What is the formula? Problems. All this do go through. Moving on to the 9th week. Is covering about groundwater recharge techniques. So groundwater can be recharged naturally, artificially, or induced recharge can be given. So in this portion, firstly, they discuss about natural ways to recharge groundwater through gully plugs, contour bunds, gabion structures. What are all of these? You should have an idea, because they'll give a description of that and they'll ask you what kind of natural recharge technique is it? Is it a gully plug? Is it contour bund? Or is it gabion structure, or is it a check dam, groundwater dams, or dug well recharge? So these are some natural ways to recharge groundwater. Here, which of the following is constructed across small streams streams having gentle slope? It is check dams. So do go through what are these structures and where they are given. Then another question is the groundwater recharge estimation through 2-3 methods. One is the groundwater balance method, rainfall infiltration method. So this is problems relating to that can come. So you can have you can be familiar with the formulas: groundwater level fluctuation method, groundwater balance method, and rainfall infiltration factor method to estimate groundwater recharge, not groundwater flow, groundwater recharge. So problems relating to that can come. This is one such example of the problem. Again, another example of the groundwater level fluctuation method. Another concept covered is what is this fluctuation? It is the water table in the post-monsoon period minus water table in the pre-monsoon period, and it is measured in terms of meter below ground level. So questions relating to that was also discussed. Then about what are the groundwater resources in a country, which administrative unit is taking care of the assessment of groundwaters. It is the Central Groundwater Board as well as the boards in the state governments. So what is the total annual groundwater recharge? What can be extracted? What can be used? How much is being used for irrigation and domestic purposes? This portion always have a question from it. So do be familiar with this portion. So this is how much amount of total annual groundwater recharge has been assessed by the Ministry of Jal Shakti. So the slide has all of those data in it. Then again, what is rainfall seasons in a country? The southwest monsoon and the northeast monsoon. What is the period of those rainfall is also important to know. We have the winter, summer, monsoon, and post monsoon. When is winter? Generally from December to February. Summer is from the middle of March till May. Monsoon is from June to September, and post monsoon, the autumn season, is from October to November. What is the calendar groundwater year? It is 12 calendar months beginning with the commencement of dominant predominant monsoon. Sorry, the commencement of predominant monsoon. Predominant is an extra word over there. Sorry about that. So what is a groundwater year? What is groundwater assessment year mean? Then what are the types of groundwater assessment units? It's divided into block, taluk, mandal, and watershed. Then what are the subunits? Again, hilly area, poor groundwater quality area, command area, non-command area. So what are all these subunits? The subunits, you can know what is a hilly area, what is this poor area, what is command area, non-command area, what is the so the definition, you just have to have an idea about what all these terms mean. And again, on the categorization of the command and non-command area is there under safe, semi-critical, critical, and overexploited. So what are all these are something that you might have to focus on. So we discussed all about this groundwater resources in India, natural ways to recharge, estimation of groundwater recharge to the three method, groundwater assessment units, subunits, and its categorization. Another concept that is covered in the weeknight is TAR, which is total annual replenishable recharge, and computation of groundwater development using TAR. So what is TAR? Then there is 6 steps or something in computation of total annual replenishable recharge. In that, they're asking how to find the net draft, how to find the groundwater development. There are small formulas for all that, so you can focus on that as well. Moving on to the 10th week. 10th week is taking care of groundwater management techniques like scientific management of groundwater resources, that is classified into supply side and the demand side. So what are supply side measures? It is taking care of the supply of the water, how much maximum, what is the maximum quantity of groundwater we can extract without affecting its availability or affecting the resources. Demand side is taking care of preserving, protecting, and controlling the amount of water that is provided. So what are the objectives of supply side measures? What are the again, there is this portion covered is for the need for the groundwater management techniques. So questions related to that can come. Then, yeah, what are the major source? Another important area is the watershed classifications. What is a watershed? What is a sub watershed? What is milli, micro, mini watershed based on the area? So they'll give you the area and they'll say which out of this is micro, which out of this is mini, which out of this is sub watershed. So here again, supply, what are the demand side measurements? It is ownership of groundwater involving stakeholders, proper monitoring and implementing, proper pricing of water. All these are demand side measures. So they'll ask all of these and say what kind of measure it is. Is it a supply side measure or is it a demand side measure? Then again, another term introduced here is the sustainable groundwater resource management. What is sustainable resource? What is not non-sustainable practices? So what are the practices that come under non-sustainable practices? You can go through it. Questions related to that can come. Then these are some of the questions that are the coming in with respect to sustainable use of water. Then another portion that is covered here is the management of groundwater through artificial recharge, or what are the different techniques of management of groundwater. So we studied about scientific measures in management of groundwater. Then how can groundwater be managed? Through artificial recharge, through conjunctive surface water and conjunctive use of surface water and groundwater, interbasin transfer, intrabasin transfer, indirect or induced recharge, and control wells. Some of the methods in which groundwater management can be done, implemented. So you can go through all of that. Then what is watershed modeling? What are the classification steps involved in watershed modeling? What are the classification of watershed models? And examples of it. And another concept that is covered here is the integrated watershed management approach. What is the concept? What is the objectives of it? What is the strategies adopted in integrated water management? Go through all of that. A question is likely to come from that. So there are a lot of questions which is being discussed in the problem solving session as well as in the assignments that are covering these portions. So do go through the questions for that. So we focus points of week 10 are these. What is the need for management? The challenges, common goals. What is scientific management of groundwater resources? The supply side measures and the demand side measures. Then what is watershed? The watershed classification and modeling, integrated watershed management. Then groundwater, different methods of groundwater resource management techniques. What are the different stages of groundwater management development and management techniques? That is, we have the baseline, incipient stress, critical stress periods, and also at what time what kind of management or development technique is suitable for what kind of situation? Well, baseline is when water is available water is available fully to meet all of their requirements. When incipient stress is when water is available, but then there are some small conflicts regarding groundwater. So based on the stress conditions, there is a stages of groundwater management development. So that is also something that you might need to go through. Then sustainable, non-sustainable water resource management technique is another area of focus in the week 10 lecture. Moving on to the 11th week is focusing majorly on rainwater harvesting. So what is the need for rainwater harvesting? Excuse me for a minute. Okay, so we were talking about the 11th week's lecture. In this 11th week, what is the need for rainwater harvesting? Why we are implementing rainwater harvesting is one portion. Then another one is what are the uses of rainwater? How can rainwater harvesting system implemented? The water, how in what all ways can we use it? Then what are the components of a rainwater harvesting system? It has a catchment to collect the water, it has a delivery system to transport the water, and it has a storage system to store this water and then distribute it accordingly. A more detailed explanation of the components is the first flush, the filtration system, and all this. So details about the entire thing is given. What is catchment area? What all can be used as the catchment area? What are the systems of transportation? What is first flush? What are filtration system? There are sand filters, PVC pipe filters. So what are all these? What kind of materials are used, and for what area is this used is sort important. Here, this is one question. 6 inches pipe is enough for 1,500 square feet. 8 inches pipe is required for area more than 1,500 square feet. So problems, I mean, questions relating to that can come. Then again, methods of artificial groundwater recharge. So for in week 10, week, this is week, this week. This is 11th week. In week 10, we had looked at natural methods of recharge. Now we are entering into artificial groundwater recharge. So artificial groundwater recharge, one of the methods is through rainwater harvesting. That is to building structures so that groundwater can be recharged. It is divided into two methods: direct and indirect. Indirect is induced recharge. That is, we are creating a situation where the streams will provide water into groundwater. And direct recharges through construction of structures that will collect the surface water and recharge the groundwater, or subsurface structures that will help in recharging groundwater. So these are some broad classifications of artificial recharge, and all of the details have been given about surface recharge techniques through steam augmentation, ditch and furrow system, basins, flooding, what is recharge well, what is dug well, what is recharge pitch or shaft, what areas or what where it can be constructed. All of that specifications have been given, so you will definitely have to go through it. This is what I was talking about, induced recharge. Okay, so that, okay, then again, like I said, what are the different types of recharge structures that can be constructed? Recharge trench, recharge pits, recharge pits and shaft. All these are the specifications of it. What should be the depth? What should be the width? What kind of areas these are used for is something that you will have to study and remember. Then what are the different sources of water for recharge? You can collect water from rooftops. You can collect water from that is flowing down paved and unpaved areas. You can collect water from water bodies, stormwater drains, etc. So that is another area of focus. We discussed about the components of rooftop harvesting. What is first place, what is the storage system used, what are the filtration system used. So all of these are what is majorly covered in week 11. Then what is artificial recharge? We say artificial recharge, we say natural recharge, but what exactly is artificial recharge? Artificial recharge is the process by which groundwater is augmented at a rate higher than the natural percolation. So in an area, if there's natural percolation of water happening, then artificial recharge is going to add water to the groundwater at a rate which is higher than its natural percolation. Otherwise, it is not called artificial recharge. So, which regions it is important, and what are the techniques that can be used for artificial recharge? Here, there are a lot of structures that can be used for artificial recharge as well as rainwater harvesting. So, do go through all of that in detail. Where is a recharge well or an injection well provided, when the aquifer is shallow or when the aquifer is deep. All these are important points. So focus point of week 11 would be rainwater harvesting. What is its need and what are the different components? Rooftop harvesting. Rainwater harvesting, one method of rainwater harvesting is rooftop harvesting. So what are the components of rooftop harvesting? Then what are the sources from which you can do rainwater harvesting? Like I said, rooftop is one method in it. Then what are the components of rooftop harvesting? What is artificial recharge? What are the methods of artificial recharge? What are the structures that can be used for artificial recharge in rainwater harvesting? This entire chapter is focusing on that, this entire week. So do go through it. Lastly, when we come to the 12th week, this was recently taken in the last week, so I didn't go to put in the slides. This is majorly focusing on what is global warming, what is greenhouse effect, what are the greenhouse gases, then what is the potency of greenhouse gases with respect to carbon dioxide, what is the effect of global warming on water resources. We saw how increase in temperature is going to change the chemical and physical composition of water. How is it going to result in ocean acidification? How is it going to impact corals? All these are some impacts that we had looked into. It is going to change the physical and chemical composition of coastal area, the sand, the water in the coastal areas. So these are some points that you'll have to focus on. What is the effect of climate change on groundwater resources? This is another important area in this week 12. Then another focus area is projected climate change in India. That is, in the future, the how is in the next century, what is going to be the climate in India, what is going to be the difference. The rate of evaporation is going to increase, then runoff is going to increase, and in the next century, the projected climate change is nothing but what has been estimated or predicted for the future. So how is the state going to be in the future is another area of focus in the week 12. So this was all what I wanted to discuss in today's session about the focus points of all the weeks. So yes, so all of you do go through all the lecture series, the transcripts of the lecture series, the problem solving session videos, as well as material. You can go through the slides that have been provided to you. Do all the problems. If you have difficulty in covering the entire area, at least focus on these points that we have discussed today, and then try to, if you have time, go through the extra, the other areas that you were not able to cover. So that will be all for today's class. Wish you all the best, and do hope all of you can do your exams well, and have all the best to whatever aspect you're doing in life. And thank you. And this will be my last session for today. So thank you.